Okay, so for the advantages of steel as structural material, okay, it is high strength, okay, whereas it is high strength per unit weight, okay, and its dead load is small. Okay, so dead load means that the its own weight, okay, is small. Okay, so it is lighter in comparison to concrete. Okay, and it is good for long span bridges, okay, tall building, and also poor foundations. Okay, then as for the uniformity, another advantage is the uniformity. Okay, whereas the properties does not change within time. Okay, then we also have elasticity. Okay, it could provide sufficient ductility. Okay, and in terms of permanence, okay, it can last longer if it is properly maintained. Right, so if we have to apply coating, right, so therefore this coating has to be renewed, okay, through time, okay, so that we can maintain the quality of the steel. So this is more on the advantages of steel as structural material. So we can see that steel is very ductile, okay, so it can withstand extensive deformation without failure under high tensile stress. Okay, and when a mild steel member is being in tension, considerable reduction in the cross section and large amount of elongation will occur at the point of failure before actual fracture occur. Right? Okay, so as we can see here, okay, if we have a steel reinforcement, okay, or a steel bar, right? So when it is under tension, okay, where it is under a pull-out force, okay, so what happens is that our steel reinforcement will actually elongate, okay, and the diameter of that particular steel, okay, will reduce, right? So therefore, at some point, okay, after the diameter, okay, has been reduced, okay, then it will fail, right? So it fails means that it experiences actual fracture. Okay, so if it does not have this property, okay, so it will be hard and brittle and might break if subjected to sudden shock. Right, so this is this property. Okay, whereas we have hard and brittle, this is actually for concrete. Okay, whereas it is very weak in tension. Okay, whereas it cannot be bent. Okay, however, when we talk about steel, okay, it can bend, okay, and it has very high ductility, right? Okay, so under normal loads, high stress concentrations develop at various points will yield locally at those points, okay, and this prevents premature failures. And when overloaded, their large deflection give visible evidence of impending failure. Okay, then another advantage, okay, of steel as a structural material is that it can be used as addition of existing structure, right? So it means that we can add up, okay, to the existing structure. Okay, so we can add up a new base or wings, okay, added to the existing steel frame building, okay, and even for steel bridges, okay, it can be widened, right? So we can just simply use and also design, okay, the connection, okay, and the steel bridges can be widened. Okay, all right. So, and other advantages, okay, is also listed here, right? So it has the ability to be fastened together, okay, by several simple connection devices. Okay, for example, we can have welds, bolts, and also rivets. Okay, then it can be easily adapted, okay, to fabrication, right? So it is up to us, okay, to design the shapes, okay, and the connections, right? Okay, then it can be fabricated in the factory. Okay, then speed of erection. Okay, so since it is precast in the factory, right? So therefore, the speed of construction will be much faster. Okay, in comparison to a cast in situ construction. Okay, then its ability to be rolled into a wide variety of sizes and shapes, toughness, and also fatigue strength. Okay, possible to be reused after a structure is disassembled, right? Okay, because we are talking about steel, right? So steel is one of the material, okay, that we can actually melt back, okay, and recycle the material, okay. Then we can reuse the material, okay, and it is also economical, okay, through mass production of standardized items, right? So if we are doing a mass production, okay, of certain parts, okay, therefore it can be an economical economical investment, okay, of using the steel. Okay, Right, so now we move on to the disadvantages, right? So we have already discussed on the advantages. So now, okay, we are going to look into the drawbacks. Okay, right. So one is on in terms of its maintenance cost. Okay, so since we are dealing with steel, okay, so it is susceptible to corrosion. Okay, when it is exposed to air and also water. So therefore, it needs to be periodically painted and protected. Right, so we have to make sure, okay, that it has sufficient protection, okay, so that it won't corrode. Okay, then we have fireproofing costs. Right, so steel is an excellent heat conductor. Right, so therefore it may transmit heat to other sections, causing fire to start in the next building or room. Okay, and as we know, steel also has its own melting point. Okay, so it is um, also easy to be subjected to failure, okay, when it is exposed to high heat. Right, so therefore we need to have this fire protection. Okay, right. So next is susceptibility to buckling. Right, so uh, we have the danger, okay, of buckling, and it is not economical since it requires some more costs, okay, to stiffen the column against buckling. Right, so as for this buckling risk, okay, we have to ensure, okay, that the design of our section, okay, should be considering, okay, the slenderness of the column. Right, so it means that it cannot be very slender. Okay, when we have a thin section, okay, and it is a long section, therefore it can be subjected to buckling. Right, so buckling ni is kalau dia bengkok. Okay, right, then we have fatigue. Okay, when it is subjected to cyclic loading, okay, the steel strength will be reduced. Right, so when we talk about fatigue, okay, actually we are talking about repetitive loading. Right, so when we have repetitive loading on our structure, there is a possibility for a steel structure to be undergoing a reduction of the steel strength. Right, okay, so this is one thing that we have to look into. Then the last one is on the corrosion of steel. Okay, so exposed steel work, it can be severely affected, okay, by corrosion in the atmosphere, particularly if pollutants are present. Okay, so it needs surface protection. Okay, and for water soluble structures, okay, it can accelerate further the corrosion. Okay, so atmosphere containing chloride or sulfur oxide will further accelerate corrosion. Right, so for marine structures, okay, usually we will not be going to use the steel structure, okay, unless it is fully protected, okay, because it is under a chloride environment. Right, so therefore it is much easier for the material, okay, or the metal to or the steel to corrode. Okay, and this is for the steel properties. Right, so steel is ductile, okay, at temperatures above 10 degrees Celsius, but it will become brittle, okay, at temperatures below 0 degrees Celsius. Right, so we have to look into this as well, especially for countries, okay, whereas we have 4 seasons. Okay, then we have to look into the property, okay, of steel under the lower temperature. Okay, but that should be no problem in Malaysia. Right, so what you can see here, okay, in these figures, okay, are the stress strain curve, okay, for low tensile steel and also high tensile steel. So for low tensile steel, okay, the breaking point, okay, or the failure point is at 250 Newton per millimeter square strength. And as for high tensile steel, okay, the breaking point is at 460. Okay, so this listed here, okay, are the type of protective coating. Right, so as for the protective coating, okay, we have a variety of types, okay, on this coating that we can apply to steel. Okay, so the first one is active coating, okay, or cathodic protection, galvanized. So zinc coating on steel provides protection galvanically. Okay, so the zinc is anodic to the steel, okay, which is cathodically protected. So the zinc may be sprayed on the applied surface, okay, by heating the surface in contact with zinc powder. So alternatives to zinc are aluminium, which act in the same way as the zinc, and the member is coated by dipping in a bath of molten zinc in the galvanizing process, spraying or electrolytic deposition processes. Electrolytic process gives thinner coatings, right? So this is one of the example, okay, of protective coating, okay, whereas we are applying the material, okay, in order to have this active coating. Okay, then the second one is barrier coating, right? So we have various types, okay, under barrier coating. So we have inorganic. So this includes enamels and cement. Okay, although it is usually taken to mean thin barriers produced either by surface modification or by painting, right? Then organic is thick coating of substances such as pitch, tar, and bitumen, okay, are useful for steel structures to be buried in earth, usually in association with cathodic protection. Okay, so in the cathodic protection, the cathodic partner is protected by the corrosion of an anode by imposing a current so that the area to be protected is made sufficiently cathodic. Right? Okay, so we are going to use a current, okay, in order to protect the steel structure. Okay, so painting of various systems are used. Okay, so one common system consists of using a primer of zinc chromate following by finishing coats of micaceous iron oxide. So the paint system normally consists of primer, undercoats, and also finishing coats, right? So we can also use painting in order to protect our steel. Okay, so paint can give good long-term protection if applied by brushing and spraying. So all paints are permeable to air and water, and water vapor, okay, to some degree, and the protection afforded, okay, is directly proportional to the thickness of the paint, right? So if we are using this method, okay, if we are using paint in order to protect our steel, okay, we have to ensure that we have the maintenance process, okay, whereas we have to look into the paint, okay, over time. Okay, so we need to do maintenance, okay, to the protective layer. Okay, the next one is plastic coatings. Okay, so steel, especially in sheet form, can be coated with protective and decorative plastics. Okay, the coatings are adherent and can withstand mechanical shaping methods such as folding and even deep drawing. So they are usually used for cladding and also roofing, right? So we can also use plastic coatings, right? So it is almost similar to painting. Okay, however, this plastic coating has another layer of plastics, okay, to actually protect the steel material. Okay, right. So here I'm showing you the examples, okay, of the steel structures, okay, that can be used in the civil engineering application. Right. So we first one we have universal beam. Okay, it is very efficient for resisting bending moment about major axis. Okay, then we also have a universal column, right? So a universal column will be used as a vertical element. So it is to resist action load, okay, with high radius of gyration about the minor axis to prevent buckling in that plane. Then we also have channels. Okay, it is used for beams, bracing members, truss members, and also in compound members. Then we also have hollow sections, okay, produced from flat plate. So we have circular section, okay, is made first. Then this is converted to the square or rectangular shape. Okay, if we wish to have other shapes, okay, right. So we can have circular shape, or we can also have square or rectangular shape. Then we also have angle and T, okay, produced by cutting universal beam or column into two parts. And it is used for truss members, ties, and light beams. Okay, then we also have compound sections, okay, as what we have already discussed earlier, right? So when we talk about compound sections, okay, it means that we have our main structure and connected to plates. Okay, so we have examples here, whereas we have universal beam covered with cover plates. Okay, so we have cover plates here. Then we have two channels, okay, that are welded together. Okay, then we also have two angles welded together. Okay, right? So we can see here, these are considered as compound sections. Okay, then we have built up sections. Okay, so built up sections. Okay, whereas you can see that we have sections that we weld together. Okay, and these are the examples. Okay, and this is a steel staircase. Okay, and these are for wire strands and bars. So these are actually for pre-stressing purposes. Okay, so we have wires. Okay, so as you can see here, these are known as wires. Okay, then we also have steel strands. Okay, whereas these wires is combined together. Okay, to produce strands. Okay, and we also have steel bars. Right, so this steel bars is usually for the steel reinforcements. Okay, then we have buckling and blind rivets. Okay, right. So this is where we have the connections. Okay, so we have buckling. Okay, and also we have rivets. Okay, right. So I think that will be all. Okay, for the steel material. Okay, so thank you very much. Assalamualaikum.